Chapter 8-5 is called the Law of Sines. And what's nice about Chapter 8-5 and 8-6 we'll see are different than the rest of the chapter because they deal with finding lengths and angles when we don't have a right triangle. So far everything we've dealt with has been right triangles. SOHCAHTOA can only be used with right triangles. We're going to see in this section and the next section that law of sines and law of cosines is a way to use trig, sine and cosine, without actually having to have a right triangle, without having to use SOHCAHTOA. So it's a nice feature that we have when working with trigonometry. Now, to get started here, how we label our triangle is going to be important when defining law of sines. So typically when labeling the vertices, we use uppercase letters, and to label the sides, we label it with a lowercase letter across from the angle it corresponds to. So what I mean by that, if I label this vertex here, capital A, then I would label the side opposite that angle, lowercase a. Similarly, if I label this angle down here, capital B, I would label the side opposite it, lowercase b. And lastly, if I label this top vertex angle capital C, then the bottom side would be lowercase c. So when we're talking about corresponding angles and sides, the side opposite the angle are the two we care about. Those are the two that correspond. So now let's go ahead and look at this law of sines. Remember, this is what we use on non-right triangles. And it says if you know the measure of two angles and the length of a side, so either set up as AAS or ASA, or two side lengths and the measure of a non-included obtuse angle, SSA, then you can find all the other measures of the triangle. So the first part of this law of sines definition is just setting up what we talked about above, using capital letters for the vertices or the angles and the lowercase letters for the opposite sides. Law of sines then relates the sine of each angle to the length of the opposite side. We can see that here. Sine of angle A divided by the side opposite it is equal to sine of angle B divided by its opposite side equal to sine of angle C divided by its opposite side. So anytime we know an angle and the side opposite it, we can set up law of sines to find a missing angle or side. Now, as a definition, I feel like it's not super clear how to use this. Let's go ahead and try it in a practice problem, and hopefully you'll see that it's actually a pretty neat, swift little process that we can use. So problem 1 says that in triangle ABC, the measure of angle A is 48, measure of angle B is 93, and AC has a length of 15. To the nearest tenth, what is the length of BC? Just like with the last section, I would not recommend approaching a problem like this without sketching yourself a picture. Without a picture, you're most likely going to make some minor errors just in not having it set up right. I'm just going to sketch any triangle. It really doesn't matter if it's drawn to scale or looks like it's accurate. And I'm going to set up my vertices here and plug in what I know. I know the measure of angle A is 48. I know the measure of angle B is 93. And that AC has a length of 15. Okay. What am I looking for? To the nearest tenth, what is the length of BC? That's this side here along the left. That's what I'm looking for. So let's use that law of sines. And remember, law of sines related an angle measure that we knew with a side opposite it that we know. So let's start by locating an angle and opposite side where we know the measures of both. And hopefully you can see that here. Since I know the measure of angle B and the length of AC, I can pick those to get started with my law of sines. I know the angle measure and I know the length of the opposite side. So I'm going to start by setting up sine of angle B, which is 93 degrees. So sine of 93 divided by the opposite side, we could call this lowercase b if we wanted to, so 15, equals, now what do I set this equal to? Well, I'm looking for this length CB here, this missing x. So I need to use sine of the angle opposite it to find that missing length. So I'm going to say sine of 48 over, now in this case I don't know the length, so that's going to be my variable, x. So now I've got one equation and one variable. I'm going to use cross multiplication to solve. X times sine of 93 equals 15 times sine of 48. To get x by itself, we're going to want to divide both sides by sine of 93, because remember, sine of 93 is just some number. It's probably not a very nice number, but it's still just a number. So that gives me x, or length BC, is equal to 15 times sine of 48 divided by sine of 93. So let's practice putting that in our calculator. Again, make sure that you have a calculator that can do trig functions, and make sure that it's in degrees mode. So for this calculator, I can tell it's in degree by the purple DEG at the top. If you're not sure how to tell, it probably is, but it's possible it got switched to radian modes, and that would give you an incorrect answer. So just be sure to ask if you're not sure. So when we want to pull this into our calculator, we need to start by finding 15 times sine of 48 first. 15 times, in this calculator, I'm going to put in my 48 first, then select sine, then make sure that you click enter after 15 sine of 48. That's giving you the numerator. Now we want to divide that by sine of 93. So 93 sine, and again, make sure you're clicking enter. We get an x value of about 11.2. That tells us BC, the length of this missing side here on the left, is equal to 11.2. So setting up your law of sines, cross multiply, plugging it into your calculator. Now our next problem says, use that same triangle ABC, but now let's find the length of AB to the nearest tenth. So I'm just going to use the same picture. It's going to get a little bit ugly, but I'll try and keep it clean. So AB is this length here. I'm going to call that Y. Notice I don't know the angle measure of the side across from AB. So if I don't know the length or the angle measure, I can't go ahead and use law of sines yet. Notice, or hopefully you maybe had some sparks flying when we were filling in our triangle, I do know the other two angles. So I can actually find the measure of angle C by using triangle sum. 180 minus 93 minus 48 will give me the measure of that missing angle, which is 39 degrees. Now I can find Y since I know the angle opposite it, again using law of sines. I'm going to start the same way I started the last one, and we're going to do sine of B over side B, or sine of 93 over 15, equal to, now instead of using the side and angle I chose last time to find X, I'm going to use Y and its opposite angle, 39. So I'm going to set it equal to sine of 39 over the side length, which is Y. And let's cross multiply to solve. Y times sine of 39 equals 15, Y times sine of 93 equals 15 times sine of 39. And divide both sides by sine of 93 to get Y by itself. If you have a calculator, practice doing this on your own. Pause the video and make sure you get the same answer that I do. So Y is equal to approximately, let's go ahead and throw that into the calculator, 15 times sine of 39, enter, divided by sine of 93, enter, about 9.5. And again, that was finding the length of AB. So we were able to find all angle measures and all side lengths when we were given two angles and a side. Now, be sure to note, when I started my second process, finding the length of AB, I could have started, instead of using angle B and side B, I could have used angle A and side A, since I had just found that angle measure, or that side length to be 11.2. The reason I didn't is because I had to round here. 11.2 is an approximate answer. Anytime that you can use exact answers, do that instead. Another reason that it's better to start with the ones that are given to you is just in case you made a mistake. If I had maybe just pushed something in my calculator wrong and gotten a wrong answer for the length of BC, if I used that to start my proportions there, I would have got a wrong answer again for side AB. So a good rule of thumb is to use the angle and the opposite side that you're given, even if you know another one from the process you've completed. All right, let's try another one. And this time, instead of finding a side length, we're going to use law of sines to find a missing angle. So we're told we have triangle RST, where RT has a length of 11, ST has a length of 18, and the measure of angle R is 120 degrees. To the nearest tenth, what is the measure of angle S? Again, I wouldn't recommend approaching this without sketching yourself a picture. So let's draw a picture here. And I'm going to label it RST like this. And again, fill in what you know. I know RT has a length of 11. And ST has a length of 18. And the measure of angle R is 120 degrees. Hopefully right now you're starting to see, good, we can use law of sines because I do have an angle and the side opposite it. I'm set up to use the law of sines here. Now, what am I looking for? What is the measure of angle S? I'm looking for this angle here. So let's set up law of sines starting with what we already pointed out, angle R and the side opposite it. So sine of 120 degrees over the length of the opposite side is 18 equals sine of S. I don't know S. That's actually, we're just going to leave that as angle X over its opposite side, 11. So again, I do just have one equation and one variable. I can solve this, but it is going to take me one step further than what we did in the previous problem. We're going to begin the same way, though, by cross multiplying. So I get 18 times sine of X equals 11 times sine of 120. And now notice that instead of my X being out front, my X is inside that trig function of sine. So the first step I'm going to do is I'm actually going to get rid of this 18. To undo multiply, we divide. So I'm going to divide both sides by 18. And I'm going to get an answer for what sine of X is equal to. Sine of X is equal to 11 times sine of 120, all divided by 18. Let's do that much first, and then we'll go ahead and do that final step of simplifying for X. So let's figure out what 11 times sine of 120 over 18 is. 11 times 120 sine, enter, divided by 18. And in this case, try not to round till the end. Try to leave this in your calculator and use that number if you can. So that tells me that sine of X is equal to about 0.529. But I don't care what sine of X is. I want to know what X is. I want to know what that angle measure is. Hopefully from section 3 now, you're remembering the process we can use to undo sine. To undo a trig function, we use what we call inverse trig functions. So to get X by itself, we're going to say X is equal to the inverse sine of what we just found, 0.5292. And this is where I was saying, try to leave that in your calculator and use it if you can. In my case here, once I hit the second button and I get inverse sine, if I just click inverse sine, it's going to use this huge long number from the last one. So I don't have to round as much. If you can do that, you're going to get a more accurate answer. And when I do that, if I want to round to the nearest tenth, I get 31.95. Rounded to the nearest tenth is 32.0. So my missing angle here, or one of my missing angles, angle S, has a degree measure of 32.0 degrees. So kind of one step further, but still just using a process we already know. All right, let's try one more like that where we find the missing angle. We've got triangle KLM with LM equal to 9, KM equal to 14, and the measure of angle L 105 degrees. To the nearest tenth, what is the measure of angle K? Again, start by drawing yourself that picture. Doesn't matter if it's a pretty picture, doesn't matter if it's drawn to scale, just sketch a picture. KLM, and I'm going to label what I know. LM has a length of 9, KM has a length of 14, and angle L is 105 degrees. Again, hopefully you've got some sirens going off that are telling you, hey, this is a good one for law of sines because I know angle L and I know the side opposite it. What are we looking for? We're looking for the measure of angle K. I'm going to label that X. So start by setting up my sine with the side and the angle we know. Sine of 105 over the side opposite it, which is 14, equals, now the angle I'm looking for is angle K, so sine of X, over the side opposite K, which is 9. Very similar to the last one, cross multiply to solve. 9 times sine of 105 equals 14 times sine of X. Work towards getting X by itself by dividing both sides by 14. And that tells us that sine of X is equal to 9 times sine of 105 over 14. Even though we don't care what just sine of x is, we're going to start there so that we can then use our inverse sign to solve. So 9 times sine of 105 divided by, oh, and I didn't click enter this time. That would give me a wrong answer. Let me try that again. 9 times sine of 105, enter, divided by 14. Again, try to leave that in your calculator if you can. So sine of x is about equal to 0.62095. But I don't care about sine of x. I want what x is. So x is equal to, remember, we undo sine by using inverse sine. And if you can in your calculator, leave the number, get your inverse options, and take the inverse of that value. We get about, rounded to the nearest tenth, 38.4 degrees. Okay. And now we could find the missing angle M by using triangle sum. All right, our last one, we're going to practice finding two different lengths in the same triangle. We have a ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast. At sea, the captain cannot determine the distance by observation. The triangle formed by the lighthouses and the ship is shown. Can the ship sail safely to either lighthouse? So we have a lot going on here. They did give us a picture, and they're telling us that it's a 70-degree angle to get back to Port City Lighthouse and a 52-degree angle to get back to Covetown, and that along the shoreline, these two lighthouses sit 40 miles apart. We need to decide what the length of each of these, the length of the distances between the ship and each of these lighthouses is in order to see if we can safely travel back to both. So we're going to call this length x and this length y. Now, notice I have the angle measures here, 70 and 52, but I don't have I don't have the angle that the ship forms with each of those lighthouses. So to find the ship angle, we're going to have to use triangle sum. 180 minus my other two angles, minus 70 minus 52. That gives me 58 degrees. Now that I know that angle, notice I have an angle and the opposite side length. Before having that angle, I didn't have an angle and an opposite side, so I needed to do triangle sum to get that set up. Now let's start by finding x. So I'm going to start with, just like I always do, the sine of the angle I know and the opposite side length. So sine of 58 over its opposite side, which is 40, equal to, and I'm going to start with x. So I'm going to use sine of 52 over, I don't know the side length, we're going to call that x. Now this is, we're looking for a side length, so I'm not going to have to use inverse sine here, but I am going to start by cross multiplying. X times sine of 58 equals 40 times sine of 52. Isolate the x by dividing both sides by sine of 58. And x equals, let's go ahead and throw that into our calculator, and we'll round to the nearest tenth. 40 times sine of 52, enter, divided by sine of 58, enter, about 37.2. So what did we just find? We just found that the distance from the ship to the Port City Lighthouse is about 37.2 miles. Now, let's find the distance from the ship to the Covetown Lighthouse. Again, start with what you're given. That way you're not using a rounded answer. You're not using an answer you found in case you did make a mistake. So I'm going to start with sine of 58 over 40, the angle I know in the opposite side, equals sine of, if I want to find y, I'm going to use the angle of 70 degrees. Sine of 70 over y. And again, we're going to cross multiply to solve. Y times sine of 58 equals 40 times sine of 70. Divide both sides by sine of 58. And y is about equal to, throw that in our calculator, 40 times sine of 70, enter, divided by sine of 58, enter, about 44.3 miles. So what do we find there? We found that this distance is 44.3. But always make sure that you're answering the question that's being asked. The question is, can the ship sail safely to either lighthouse? Well, he can only has enough fuel for about 42 miles, and it's over 42 miles from the ship to the Covetown Lighthouse. It's about 5 miles under to the port city. So he should be able to safely he should be able to safely sail to the Port City Lighthouse, but not the Covetown Lighthouse. So make sure that you're answering that final question. So law of sines works anytime that you have an angle and the side opposite it. Section 6 will look at what happens when we don't have an angle on the opposite side, when we can use law of cosines.